Now, I have two types of circuit. Can you tell us what type of circuit?
Series and
What
parallel.
makes it series?
There's only one current path.
One path to the current. One path to current.
There's in the parallel.
Multiple paths.
Okay, multiple path to the
Some are
current.
blocked by resistors.
Multiple path. Path to current. I for current. I is the symbol
For current.
for current. Okay. So one path for current, as you see that the current goes from positive to negative terminal. If the wire breaks, what happens?
The
All the
circuit
bulbs go
stops.
dark. All the bulbs go
Dark.
dark. Okay. So if this wire breaks, the current
The current tries
tries,
another path.
and then if it sees it breaks, and then it comes back and try this path. Does that make sense?
Yeah, so parallel is maybe like a better current,
Of course.
Yeah.
Of course.
but it seems more expensive, so that's why it's not always used.
It's more practical. It's
Yeah.
no, not expensive. It's more practical to do that. Okay. So these are the rules for the series circuit, and these are the rules for parallel circuit. The first rule is, what do you see? That the current is same across the
circuit.
circuit. That means if the current over here is 1 amps, current over here is
always
1
going
amp.
in
1
this
amps.
one direction.
What about the voltage? Voltage drops. So total voltage is equal to sum of
Voltage.
at each
Each
Terminal.
as each bulb,
Oh,
right?
Yeah.
Okay. And what happened with the resistance? The total resistance is the
Sum of all the resistance.
sum of all the resistance of.
You're
The
pointing
circuit.
to the wrong rule instructor. I can't make out which is which.
Okay. All right. Let's go again. The total resistance is the sum of each resistance. How many resistor we have?
3.
3. So total resistance is the sum of all 3.
Resistance. So 2 plus 4 plus 6 is 12.
12.
That's right. All 3 resist. Okay. All right. The sum of voltage drops equal to total
Voltage.
voltage. Okay. Sum of all voltage drops is equal to total voltage. That means the voltage is 24 over here, right?
Mm-hmm.
What is voltage over here?
0.
0.
No.
So this resistor gets 24. This resistor gets less than 24, and this resistor gets the least amount of voltage.
So
By the
like
time
24, 16, 8, and then by the time it reaches the negative terminal, it's
Zero.
at 0, and
Right.
then it refills with 24 volts when it gets to the
right,
plus.
let's see the another scenario. Let's see the another scenario. Current is now same in the parallel circuit, but what is same?
Voltage.
The
Voltage.
voltage is same across the
Entire circuit.
Circuit.
entire circuit. What about the current?
The current is
The total current is equal to sum of
Current at each bulb.
at each bulb. And what about the resistance?
Equals at each resistor.
And there is a word reciprocal. So
Oh.
in
so
this
1 over R.
in this case, if you increase,
R equals to 1 over R, 1 plus 1 over R.
that's right. So in this case, if you increase the resistor, the total resistance get
Increase.
increase. If you increase the
Oh.
resistors, the total resistance
Decrease.
decrease. Now I'm going to give you 1 minute to turn them to a mathematical formulas. So how many mathematical formula you have to write?
6.
1, 2, 3, 4, 5, 6. So how long you think you need to turn them to a math equation?
1 minute.
1 minute?
So
Okay.
that's 10 seconds.
Alright. So now check your answer with me. Same current means what?
I1.
I for current. I is equal to
I1
I1
equals I2
is equal or plus?
Plus I
equals
Equal.
do equals.
I2 is equal to
I3
I3. So I'm going to write I1 and I'm going to write I2 and I'm going to write
I3.
I3. They all are the same. So total current is the same. Whatever the total resistance.
The resistance is equal to R1 plus R2 plus R3.
So total resistance is R1 plus R2 plus
R3.
R3. What about the sum of voltage? Voltage drops. What are you talking about?
Oh,
So
V
total
equals
voltage is
V1 plus
V1,
V2,
V1, V2,
V3.
and V3, right?
Yeah.
V3. V3 is this one.
So V1 plus V2 plus V3.
Okay. Now let's go over there. Same voltage. How can you write that? Voltage is equal to V1.
Equals
We
V2.
can call V1 this one. V1 is equal to V2 is equal to,
V3.
so V2 is equal to
V3.
V3. Total current. How can you write that?
I equals I1
I1
plus
is equal
I2
to I2 is equal to
I3
I3. So I is equal to I1 plus I2
plus I3.
I3. Now resistor, how many resistor we have, Isaac? 1, 2, 3. So resistor 1 over R is equal to 1 over R1 plus
1 over
1 over
R2
R2 plus 1 over
R3.
R3. Now lesson. Let's go to the lesson now.
Isaac, can we work together?
Okay.
But you never help me. You always say you will.
You always did. You never helped me.
Okay. Now how can we calculate the total current over here? Let's calculate total current, but let's erase the definition since we have the formula. So we're gonna have more what?
Space.
More space. More space.
Isaac, you wanna figure out the first problem?
Okay. Now we also gonna put something called a
The Ohm's law.
table. Now Ohm's law here. What is the Ohm's law, guys?
VIR.
VIR.
So V goes on top.
VIR. So V is equal to IR. I is equal to
V over R.
and R is equal to
V over I.
I. Okay.
And it's simple to conduct this using any cross multiplication equation. For every cross multiplication equation with 3 variables, the triangle is just A on top, B and A on the left, and C on the right.
That's correct. Okay. So total current. How can we find the total current? Before we find the total current, let's find the total
voltage.
resistance. So what is the total resistance?
2 plus 4
plus 4
plus 6.
12.
plus 6 is equal to
Let me see.
12. 12 what?
Amps.
12 not amps. 12
Voltage.
ohms.
Oh.
Okay. This is resistance, not resistivity. For resistivity,
Ohm per meter.
ohm per meter. Very good. This is resistance.
Because the cross-sectional area in the length.
Very good. So what is the total voltage?
Let's see. 24
24 what?
amps. Volts.
24 volt. Now how can you find the current?
Use VIR.
So this is number 1, this is number 2,
2.
and this is number 3. So total current is
V over R.
V over
R.
total current is V over R.
It's 2 amps.
So 24 voltage
Over 12.
over
12 amp.
24 voltage over how much?
12 volts
12
12
ohm.
ohms.
equals 2 amps.
2 amps.
Or
Oh.
ampere.
Okay, now we're gonna now create a table. We're gonna create a table. In this table, what are we gonna have? 1, 2, and 3. And then we're gonna have what? Resistor. And then we got 1, 2, 3. 1, 2, 3, and total. Okay? You follow me?
Yeah.
Resistor, and then what do we have?
Voltage.
We have a we have current, and we have a
voltage.
voltage. What is the resistor at 1, Isaac?
2.
2.
2 ohms.
And then
Let's see. I don't see 4 ohms.
4, 6, and the total we got how much?
12.
So 12.
12 ohms.
Okay, 12. Very good. Current.
24, 24, 24.
Current. Try again.
Oh.
Wait, so now can we fill in the voltage first?
Oh, voltage, sure. What is the voltage?
Um,
Voltage, we have to do that. Before voltage, we have to do current. What is the current?
2,
2,
2,
2,
2,
2.
2.
Yeah. So remember, this is a special type of math. 2 plus 2 plus 2 is equal to
2.
2 by Ohm's law.
Oh.
2, 2, 2 is equal to 2 by Ohm's law. Now let's find the voltage. There is a voltage drops. How much voltage goes to I1? How much voltage goes to R1? 24. And voltage is what? By definition, voltage is
24.
IR. So I is how much?
Okay, well, I
2.
is 2.
And R is
The total is 48 for the
4. 4. It consumes.
No. For total voltage is 48 volts,
No,
right?
no. It consumes how much voltage?
4.
It gets 24. It consumes how much?
Yeah, 4.
And it spits out how much?
20.
20.
But we want it to be equal so that it reaches 0 when it gets to negative.
Yeah, it's gonna go to 0. So how much voltage is guess? The first one.
So
4.
then take it 20, spit
Four.
to 4
Hold on,
out,
hold on.
gives you 16.
Hold on. This gets 4. Now let's see how much this one receives.
2
How much this one received?
times 4.
20. But how much this one used?
8.
8.
Let's see. I is 2 and 4, 8.
Yeah.
8. So this one this one consumes how much?
8.
8. Then how much
Um,
comes out? How much comes out? 8. 8 minus
12.
20 is 12.
12.
So 12 comes out.
Yeah,
This one gets 12. How much this one consumes?
12.
12. So how much comes out?
0.
wait, 24.
So is this 24?
Let's see. Yep.
It's 24. So voltage drops. Voltage drops by how much? 24 to 20 to
12.
12 to
0.
0. Can you repeat?
24 to 20 to 12 to 0.
To 0. So this is called voltage
Drop.
drops. Okay. Now let's do the other one. What do you think, or should we do it tomorrow?
No, I think we are.
We can do it today, right?
Yeah.
So what is the total voltage?
Okay, so
This is amazing. Total voltage is?
IR.
No, total voltage is 24. Remember, voltage is same across the
Oh,
circuit. Voltage is same. Okay, now current. Current we're gonna come later. Before current, we have to do this one.
Because I is real
I is really varies, right? I is the total current is equal to sum of the current at each bulb. So we have to do this way. So what is it?
so it's gonna be 1 over. Let me see. 1 over 2
1 over R is equal to 1 over 2
plus 1 over 4
plus
plus
1
1
over
over 6.
6.
So that would be 2.
So let's see.
3 over 4.
So 12,
And then,
Let's
wait.
6 and 3 and 2. So 10 over 12, right?
What
So
is it?
11 over 12. Sorry.
6
over
11 over
3.
12.
plus 2. So 11 over 12.
11.
1 over R.
Equals 11 over
1 over
12.
R is equal to 11 over.
So R is equal to 12 over 11.
11 R is equal to 12. So R is equal to
12 over
12
11.
over 11. Can you use the calculator, Charlie?
Yep. Let me just calculate it right now.
I can do it for you. So 12 divided by 11. 1.09.
1.09. 1.09.
And it keeps going on forever. But that's
Approximately, right?
Yeah.
Approximately 1.
09.
09.
So it keeps,
Now-
the 09 cycle
Oh.
keeps going
Now
on.
we're gonna make a table like this right here. Remember the Ohm's law. You're not gonna forget the Ohm's law, right?
No.
I don't think so. Ohm's law is like
Fundamental.
fundamental to
for electric circuits.
yeah. So this is 1, this is 2, this is 3, this is total. This is what? Let's start with what? What is same? Voltage. Voltage is same. It's easy to start with voltage.
So 24, 24.
Resistance, then current.
Okay.
So let's start with voltage 24, 24, 24, and according to
24,
Ohm's
24,
law,
24, yeah.
according to Ohm's
24.
law, it's not 72, it's 24.
Good, that's right.
Wow. Hi.
4 plus 24 plus 24 is 24 by Ohm's law. Okay. All right. So the resistance.
Two.
The resistance is how much?
2 ohms, 4 ohms, 6 ohms. No.
Okay. So it's given 2 ohms,
4 ohms,
4 ohms,
6 ohms.
and 6
Which
ohms.
will give you 12.
No.
no, which will give you
1.09.
Oh, yeah.
1.09. Yeah. This is a special case. 2 plus 4 plus 6 is 1.09 by
I
Ohm's
don't
law.
believe that in actual math.
Yeah, that's right. Don't tell your grandma. Grandma would be. What? Who told you? Grandma would say 2 plus 4 plus 6 would be what?
12.
12. Yeah,
Yeah.
but you would say 1.09 by Ohm's law. Anyway, now let's find the current. By definition, what is the current?
V R over V.
No,
V
current.
over R.
Current, that's current.
V over R.
V-I-R.
Oh,
So
V over R. That's
V
what
over-
That's what I said.
that.
V over R.
You
So,
said R over V.
so V is how much?
Oops.
So it should be what?
12.
This one 24 divided by
4,
4. It should be
6,
6. And this one 24 divided by
6,
6. It should be
4,
4. Okay, so tell me what is going on. Current is
12,
12,
6,
6,
4.
and 4. So 12 plus. Remember, we said that the
Using
definition.
Ohm's law, yeah. Using Ohm's law and regular addition, you can see that it adds up to 22.
That's right.
Yeah.
And we said that the current is total current is equal to sum of the current at
Each
here plus
bulb.
here plus here. So total current should be sum of this plus this. And what is
And
that?
we know
22.
it's exactly
Huh?
22.
22.
Is it?
Yeah, we
Now,
did that
now
math.
let's
It's
check.
exactly
Now
22.
let's check. Current is Ohm's law tells us current is what?
V over R.
V over R. Total V is how much?
24 volts.
24. And total
One-
and equivalent resistance is
1.09 amps.
1.09, and
Which
that
is
should
12
be
over 11.
12 over 11.
Yeah. So
12
if
over
we
11.
use that in fraction form, we get exactly 22.
So we are right? Now
Wow.
let's go. Check the hypothesis. Who is circuit? Oh, exit. No, exit. Who is circuit will be brighter?
Okay, wait. Which one has more volts?
Well, the same voltage.
Oh, so which one has more current?
Well, I
Let's
mean,
see.
it's the table is there.
So
The circuit. This is we're gonna call circuit 1 or series circuit. Which circuit will be brighter? The series circuit or the parallel circuit?
parallel.
The parallel. Why? The total current of the parallel is how much?
22 amps.
22 amps, and the current in the series
2 amps.
2 amps is 22 and 2 are close.
No.
So which one would be brighter?
The parallel is 11 times brighter.
11 times brighter.
And
Yes.
it's harder to cut out. So it would be like the practical method. That why don't we just cross out series circuits? Why don't we throw them out the window? Parallel is not expensive and it's a better way to sound out.
But we should not say that because the
But
current
you
started this series because remember other day when you light up the bulb using the lemon battery, it was a series circuit, right?
Oh, yeah.
Yeah, you start it small and you make it complicated. Anyway, I'll see you tomorrow.
And we also